Okay, we are officially underway. So, hello everyone, and welcome to today's webinar, Beyond AI with Luis Fernandez, Senior Research Manager at International Data Corporation, and Lapo Fioretti, Senior Research Analyst at International Data Corporation too. My name is Davide Moschella from Trust IT, and I'll be supporting the session from a technical standpoint. So if you experience any technical issues and also have any questions for our speakers, feel free to write in the chat. So I'll now hand it over to our moderator, Luis Fernandez. Thanks, Luis.
Okay, thank you so much. Good morning, everyone. Thank you for joining us in this webinar by AllPros. This webinar is actually a part of a series of AllPro webinars funded by the European Union around different topics around the semiconductor industry. Today, we'll be focusing on a very specific topic, which is emerging technologies. Today with me, I have Lapo Fioretti. He's a senior research analyst working for IDC and working on emerging technologies in Europe. So we'll be reliant on his experience in tackling this research. For my part, my name is Luis Fernandes. I'm a senior research manager also at IDC, but I typically handle IT infrastructure, data center IT infrastructure in the whole of EMEA, so including Europe as well. So let me move to the next slide. So this is us. And for the agenda today, we'll be looking at a little bit about the scope or the status of emerging technologies in Europe today. Then we'll take a look at some of the emerging technology partners in Europe. So both from the side of who's using emerging technologies, but also the companies that are developing new technologies to be used by other companies. Obviously, then we'll collapse that and we'll connect that to the impact to the semiconductor industry. How does that influence the semiconductor industry? And in the end, we'll have some questions. We'll have some guided questions for Lapo regarding these topics. And then we'll open up for Q&A if anyone has any questions, either for me or for Lapo. Just to let you know, every information that we showcase here will be this session is obviously being recorded, so you can look up the information at a later date if you'd like. Starting off, this particular slide with the executive summary is basically a summary of everything we're going to talk today. I'm not going to focus on each of these points because obviously you'll have access in the recording to them. We just wanted to showcase some of the points that we'll be illustrating in our presentation. So diving into the emerging technologies today. Lapo and his team at IDC have developed this radar chart that takes a look at some of the emerging technologies. As we move towards the center of the technology radar, we actually have technologies that are becoming common use or becoming adopted by a large number of corporations. And as we move away from the center of the radar, we actually move away to technologies that are more nascent, that are not as well developed, and some of them are still very for future use and are not in play yet in a commercial sense. That is not to say you can look at this radar and think, okay, but this particular thing we're actually using right now, and this other thing we're not using right now, but you actually consider that to be more a near-term bet rather than a watch list. This has to do with us looking at actually two different visions for these types of technologies. So one of them is actually how mature the technology is. So we can have a very mature technology, so that would make more sense to the center of the radar. But also, we also apply that to what is the commercial use and how much of it has actually become table stakes, is not something very niche. So if something might have a very developed, a very mature technology, but if it's still very niche and has not broadly been adapted by the market, then it would not be in current play. On the other hand, something that is very nascent in terms of technology, but has widespread adoption in different fields, might not yet be in current play as is, but it will tend to as the technology matures. So this is obviously very dynamic. Every year we have to introduce new things in the watch list, and typically speaking, those in the watch list will move towards the center as they become more table stakes. Regarding investment, and this is obviously a very important point, a lot of the companies we looked at in our research at what percentage of an IT budget is actually allocated to these emerging technologies in 2025. We actually also asked, okay, what about in the future? To get a sense of a comparison. But basically, in 2025, we can see that a very large chunk of companies are actually allocating around 10 to 20% of their budget into emerging technologies. That's more or less the base figure. But if we look at 92% of companies, they're actually investing less than 30%. Or therefore, everyone investing less than 30%, that includes 92% of the companies. So only about one out of each 10 company is actually investing more than 30% of their budget into these emerging technologies. And these are actually some of the companies that we'll be seeing in the second part of the presentation, which are companies that are very much investing a lot of their budget into emerging technologies. They're really driving some of these emerging technologies, especially the ones that are not very mature technologically. So when we asked, oh, and by the way, we did ask the question about 2026. The tendency is that is expected that some of these technologies will actually have a bigger part of the IT budget in 2026. So the expectation is that as these technologies mature, more companies will invest a bigger part of their IT budget. So when we looked at some of the emerging technologies that are currently being used by companies, with very not a lot of surprise, Gen AI is at the top of the list. So of the companies that we surveyed, the 370 respondents of that survey, because the survey actually envelops more countries, but of the European respondents, obviously, Gen AI plays a big part in emerging technologies nowadays. A lot of people are using, obviously, and other forms of AI as well. And 3D printing is actually quite common these days. However, there are other areas where there's still not a lot of focus. When we asked which ones are in play for the next generation, for the next few cycles of budget, people are starting to take a look at agentic AI. So probably the next step in what is going to be this AI revolution is the idea of having very small AI workloads being handled by different agents. And those different agents will have, pardon my redundancy, but will have agency. So they will be able to take action based on a set of of preliminary examinations of the information, but they'll be able to take action with very little human intervention. So we've examined some of the workloads that agentic AI might fit into, and it's things like, for example, doing real-time assessment of a threat in terms of cybersecurity. So there might not be time to analyze a lot of information, and so the agent will take measures to stop an attack from taking place by doing some action on the network to be able to stop that cyber attack in a very quick way, in a real-time way, and then report back to obviously the engineers to be able to check if that was a correct assessment or not and reevaluate. So that's basically the number one workload that we've seen that people are starting to use um, agentic AI. So these are short-term bets that we were looking into. Then there's the long-term bets. So a lot of the things that will be coming in the next few years. Um, Obviously, there's some of these long-term bets. Some part of the market is not aware of them. Others are observing, are learning, are doing exploration. That means piloting or experiencing with some of these technologies. And there's a fraction of these companies that are actually investing in these new technologies. As you can see, on the left are the most unfamiliar technologies like neuromorphic computing or homomorphic encryption. And to the right are the ones that people are more aware of or are experimenting more. There's not a lot of investment, however, in these new technologies. We've drilled down into the investment part, and a lot of these technologies are being invested either by specific industries that tend to have a return on investment, a vested interest in these technologies, or education companies. So, for example, colleges or investigation research institutes, that sort of thing. So those are actually investing in some of these technologies. On the other hand, the companies, as I mentioned, that have a vested interest. So, for example, if you look to the right to 6G, as you can imagine, most of the companies investing in 6G, aside from research and investigation, are telco companies because they tend to benefit from the use of 6G. When you look at things like nuclear technology, obviously utilities companies are the ones investing the most in this type of emerging tech, of long-term bets, because obviously they have a vested interest that will give them some return on investment. When cycling back or going back to the whole investment part, so what are some of the main barriers to why you're not adopting these emerging technologies? Um, two things stand out that are intrinsically linked. So first of all, obviously, as these are emerging technologies, they're not table stakes, so there's not a lot of companies doing it, and so prices are not very democratic. So there's a high upfront cost typically to implement these emerging technologies. On the other hand, there's a question of skills shortage. Now, this is actually something that is transversal to the whole industry, is not specific to emerging technologies. And the skill shortage is a very serious problem, even in non-emerging technologies. So we have a big explosion of the use of these technologies for companies, either emerging or the ones that are already set as table stakes. However, there's not enough skills because the skilling or the upskilling or reskilling cycle is much longer than the actual approach that we're taking to absorbing these technologies into companies. And obviously, security and privacy concern. This is something that is across all of our search, all of our research, all of our surveys. It is typically always a top concern is security and privacy. Obviously, there's a lot of concern with cybersecurity, with simple security or physical security. So there's a lot of problems there, and a lot of issues and challenges, and therefore that relates to emerging technologies as well as developed technologies. Um, as for if we ask directly to organizations, okay, what can we help you to minimize those impacts? Um, Typically companies sometimes they're very accurate in pinpointing the issues and how to solve them. So in fact, these two graphs are more or less like a sanity check of each other. So we check what are the main barriers and how would you like us to help out. And we can see that there's a lot of correlation between the two. So as you can see, the one that has on the graph on the right, the one that requires the most interference or they would like the most support is exactly in training and upskilling the resources, the human resources. So that relates quite well with the skill shortage. On the other hand, the financial incentives, companies would like to have more financial incentives to be able to handle that high upfront cost. That is the biggest barrier in terms of emerging tech adoption. Now, obviously, other components of the types of support can be applied. This is one of those situations where we have that expression called a rising tide lifts all boats, right? So, for example, in this particular case, if we develop industry-specific solutions or we develop a strong partner ecosystem, that is actually going to help. Or if we have government-led initiatives, that will help the other parts of support. So that will help with training, that will help with financial incentives. Obviously, it's a win-win-win situation. That's basically what I mean. Regarding the objectives, so we thought, okay, so you're using emerging technologies or not, but if you're using them, what are some of the top benefits? What are some of the top business goals of you adopting these technologies in your organization? A big part, again, cybersecurity always almost at the top. So the idea that cybersecurity can benefit from these emerging technologies to be able to respond more aggressively and in a more agile way to potential attacks. But also, there's a very big business acumen regarding the use of these technologies. So reducing cost, improving economic performance, expanding to new markets, grow in your own market. So that's quite interesting to see companies using these emerging technologies with this objective. Now, moving on to the area about partners, obviously there's a lot of companies that a lot of companies that both use emerging technologies and also the ones that provide emerging technologies. But what we've seen that is very interesting is that some of these technologies are so emerging or so new that a lot of the users of emerging technologies are also the ones developing these technologies because they realize the need to be able to develop these technologies to then use them in their everyday life. So it's a bit of a mix. There's the on one hand, the ones creating the technology, the ones using, but there's a very healthy mix of both. So companies that are both creating and using. Um, we looked at the profile of these companies. So most of them are in the startup or scale-up stage, which kind of makes sense because these emerging technologies are also more or less at that stage. In terms of funding, you can see that about 50% of them have raised between 1 and 50 million. Obviously, we would like to raise that number by a major figure, but we understand that there's issues with that we have to upstage to be able to address. And in terms of the European companies, typically they're a little over 10 years. And in terms of significant sources of funding, we can actually see, and this is a big difference. We've looked at this from a worldwide perspective. There's a big difference between these sources of funding in Europe and, as you can imagine, in other parts of the world. So 44% of the funding coming to these companies in Europe is coming from government grants. In other parts of the world, private equity and venture capital actually addresses a bigger part of the funds that these companies can actually secure. As you can imagine, more less averse to risk markets like the US, for example, where government doesn't play such a bigger role, and venture capital and private equity is much more adopted. Um, as for these near-term emerging techs, we have the term, sorry, I forgot to tell you that the term on the title called DNBs, those are digitally native businesses. So basically companies that were born digitally. They're not companies that were born in other areas and then are becoming gradually digital, but companies where digital is bred into the DNA of the company itself. And when we look at these, the type of technologies that they're using in their products and services, as you can imagine, like generative AI comes at the top of the list, but predictive and interpretive AI or typical AI is also almost at the top. Um, and then there's the use of creating dashboards, creating APIs, creating portals for control plane. Now, this plays a big role in IT because we've seen that one of the main priorities for companies is actually automation, orchestration, managing multi-cloud, that sort of interesting technologies that require these types of control planes and portals to be developed by these technologies. And of course, security also plays a big part in that. So when in terms of partnership, we try to look into these new companies, these DNBs. What are they doing in terms of partnerships? Who are they linking to? And we can see that they're very much linked to cloud providers. Obviously, this might be an issue because a lot of companies would like to have a more cooperative market space where they would be able to work with other startups and be able to develop or co-develop technology. However, these come at the bottom of the list. They themselves want to do this type of marketplace and create these cooperation products and services. However, it's obviously much easier to start with the established providers that are more seasoned, that are have more mature products, and therefore a lot of the strategic partners are the seasoned or the more developed providers as of yet. So looking back at some of the resistance, of the resistance and challenges and barriers to the adoption of emerging technology. So back to that question that we addressed earlier, we asked specifically this question to DNBs. Here the problem is we're not looking at the vendor ecosystem is still too immature. So exactly because it's mainly startups and scale-up phases, these companies, they don't have a mature enough marketplace for them to work together, for them to collaborate in that sense. So it's very hard to um, take the next step into becoming established players. So as we look at some of the priorities for IT spend over the next year, over the next cycle, again, like I told you, it's always security comes in first place. Generative AI obviously has a big role to play and will continue to have in the next few years. At least that's what we believe in. But we do see creeping up analytics and also agentic AI, and obviously automation. So this will be a big part of the few next cycles because automation, orchestration, multi-cloud services, the use of analytics, the use of agentic AI actually helps with fighting a little bit of that issue that we saw earlier about the lack of skills. So if you have a lack of skills, a lack of resources, but on the other hand, you're able to automate a lot of functions, that means that actually you might not need those many skills or those many resources if you actually can automate a lot of things. Now, it's still going to be an issue, the lack of skills, but at least you're trying to minimize that issue or that challenge. But it's still an issue. So, how does this relate to the semiconductor industry? Um, by looking at the impacts that the emerging technologies will have in our society. There's obviously a question always lurking that is job displacement. A lot of people fear that the use of some of these technologies will push out skilled workers out of their employment. Um, this might be true. We don't have enough accurate data to be able to say, we hear a lot of times these types of speeches where, oh, this is taking a lot of jobs, and then someone else will say, oh, but this is creating a whole set of new jobs. The question is, we actually don't have enough data at this point to be able to actually confirm which is how many jobs are being lost and how many jobs are being created because of these technologies to be able to pinpoint exactly. However, we can look at the ones that will have the biggest impact or the ones that people in charge of companies actually feel that they will have the biggest impact. So the biggest impact in society and also the biggest ROI for companies. And in that case, the various levels of AI obviously take the cake. So generative AI at the top of it, but then we see agentic AI creeping up, and even interpretive AI will have the biggest impact and will actually have the biggest return on investment for companies. Obviously, then there are the application of other types of technologies like robotics that come up twice. And then the return on investment of Wi-Fi 7 will also be very interesting. Everything related to longer period horizon technologies, those actually we see that have less of an impact when we asked people. So looking at now at some of the types of industries that we're talking about in emerging technologies. So if we divide this more or less by an industry vertical, we see that there's a lot of investment being done in Europe in different areas, but we want to focus specifically on semiconductors. Obviously, there's a lot of different projects being implemented by the European Union around semiconductors. These are just some of them. This is not by any stretch of the imagination a fleshed out complete list, even because every single day we see new news showing up in the media of new investments, new programs, new implementation of new projects. But we wanted to focus on these three because these three are will have a big impact in the European space. Um, Also, these are specific projects that are being implemented in the EU space as well. And obviously, there's more than 3 billion euros total in EU funding in 2025. And if we look at all of these around IT, then these are specific to semiconductors. The ones that are not grayed out are the ones specific for semiconductor design, manufacturing, and rolling out new semiconductor programs. Right. Um, Another big issue that we've started to see, particularly around Europe, is the question of digital sovereignty. So it has come up in the discussion with a lot of our customers, obviously because of many reasons, but mostly because of geopolitics. So the need for this digital sovereignty, although at times can be an issue, especially in the semiconductor industry, because there's a lot of codependency between different regions, so it requires us to be dependent of other regions. But on the other hand, digital sovereignty can actually be an engine of innovation and an agent of creation of new technologies, emerging technologies in Europe. So there's an idea that although it can be looked at from a challenging perspective, it can also be looked at from an opportunity perspective. So if we think about digital sovereignty and say, okay, how can we make ourselves be less directly dependent on out of Europe technology? What can we create or what can we reuse to be able to create that digital sovereignty directly at home without that much intervention from the outside? Or on the other hand, I don't defend, or this is my personal opinion, but I don't defend an isolationist um, policy around the EU with other regions. But we can create an environment of trust and partnership and codependency where we can provide some of the technology or some of the steps of the technology, and other regions will provide other steps because this is not simple manufacturing of these industries. This is very complex that takes many steps, and we can definitely help with some of these. Um, but using the development of innovation and new technology as a way to create digital sovereignty, I bring you just three examples, but these are just random examples that I looked into, which is, and mind you, if you read the small lettering on each of these, there's actually a collaboration with different regions. So it's not just a European thing, but these are examples where digital sovereignty was a question at hand, and so required the intervention of new technologies and innovation, and required the intervention of the countries or the regions to be able to keep that digital sovereignty. So I'll leave this up here, and you can check in the recording with time to read about this and look for it. But it's three examples of applying digital sovereignty that actually developed innovation, developed new jobs, developed an imaginative approach to digital sovereignty. Okay, so we'll now move on to the second part of our webinar, which is an interview with Lapo. Lapo will be kind enough to answer a few questions from us, and then we'll move on to the Q&A part of the webinar, where actually you can place your questions to Lapo live, or to me if you have any questions about the slides I just presented. So I'll get right on to the first question. So, Lapo, one of the questions that came up actually when we were starting to build this webinar is that, and I think we tried through the slides to do that, a little bit of that exercise, but I was wondering if you could tell us a bit more about the connection between those emerging technologies that are in the radar and with the semiconductor industry, obviously specifically for Europe, but more in general of the whole industry, if you don't mind.
Yeah, absolutely. Thank you, Luis, and good morning, everyone. So, specific on your question, I think it's very fair, and I think you touched on it during the presentation, but let's try to put all the points together. So, on I think there's two ways to see it. So, emerging technologies are effectively a sort of roadmap for what the semiconductor industry must build over the next years, decade, however long your time horizon may be. For example, of course, when looking at AI, but also autonomous system, advanced security, quantum, advanced materials. So virtually all of them ultimately materialize as new chip architectures, as new device types, or new manufacturing requirements. If you look specific on AI with Gen AI, Edge AI, Agentic AI, but also on AR, VR, they all depend on specialized accelerator, high bandwidth memory, and low latency. Then if we, again, I'm just referring to most of the technologies in the radar. So if you then look at zero trust, homomorphic encryption, tokenization, these require secure enclaves, crypto engines, and dedicated security processors embedded directly into hardware. And then more into the computing side, if you look at quantum, neuromorphic, photonic computing, these are themselves new semiconductor paradigms that are not just software running on existing chips. So this is one side, but this relationship between emerging technologies and semiconductors is not really one directional, because on the other side, as new chips become possible with smaller geometries, with new materials, with 3D packaging, they open the door for emerging technologies, for those emerging technologies that previously were not practical, because you spoke about the maturity and the commercialization of these technologies. For example, only when GPUs and AI accelerators became powerful and efficient enough, only then large scale deep learning and Gen AI became commercially viable. Similarly, like another example, advances in power electronics and semiconductors are what makes a fast electric vehicle charging. So the emerging technologies, on the one hand, they pull semiconductor innovation, but they're also pushed forward by it. And just to conclude, if we look specifically on Europe, and also going back to what you just presented, this has also a sovereignty dimension, because many of the technologies in the radar, AI, cybersecurity, blockchain, quantum, these are seen by policymakers as strategic capabilities where Europe should look for and want autonomy and leadership. And so, for example, if underlying chips are designed, fabricated, or controlled elsewhere, Europe may end up building European digital services on top of non-European hardware. and supply chains, and that creates vulnerability in resilience, security, and long-term competitiveness as well. But on the other hand, if Europe can anchor part of these emerging technology stacks in its own ecosystem, whether it's the semiconductor ecosystem or the overall ecosystem, so with the design, the IP, and the high value manufacturing that Europe has the capability for, it turns them into durable sources of strengths in terms of industrial strengths, in terms of export revenue, leverage. So to summarize, emerging technologies are the demand signal, but then semiconductors are the industrial backbone that turn this that signal into reality. I hope I provided a clear answer to your question, but we would need like 2 hours to get the full answer right. You're on mute, Luis.
Sorry, I put myself on mute to allow you to answer, but you're absolutely correct. I think it was clear in the sense that we can actually build the whole stack, and then obviously we'll have a major manufacturing importance in these new technologies. Or we can actually subcontract to other regions the hardware part and then add value with the software stack and the specific parts of the industry. Obviously, both of them have their own merits on their own, but they both require different types of investment. So it's something that has to be leveled out. Regarding the next question, and actually it relates to this, you talked a lot about different types of technology. So you talked about GPUs, high bandwidth memory, different types of processing units. So you didn't talk just about GPUs, you talked about security, you talked about different types. So we've seen the rise of APUs, DPUs, CPUs, GPUs, all of those types of technologies, but also VR, et cetera, et cetera. I was wondering if you had to make a bet, and I understand that this is we're talking about the future, so there's always uncertainty. But I was wondering if you could give us some of the best bets for the EU in the next few years regarding these technologies.
Yeah, absolutely. As you mentioned, I don't have a crystal ball, so it's difficult to make this kind of prediction. But let's try to put it in the European context. So, because when discussing big bets for Europe, I think that the focus should be on where Europe as a region can realistically reach global leadership or strong co-leadership by, let's say, 2030. Because we like round numbers and not just, incremental participation or where Europe is just catching up. So if we look at the emerging technologies that we spoke about, the emerging technologies on the radar and European industrial strengths, I see mostly three main areas that big bets that stand out. So there's of course the overall semiconductor, let's say, sector in terms of secure and trusted semiconductors. Then there is an opportunity in the specialized and efficient AI compute. And finally, more looking at the long term on the photonic and quantum computing platforms. So let's try to break them down with a bit more detail. So starting with the first one, with the secure and trusted semiconductors. So in terms of the context, Europe is actually has a unique combination of regulatory power on one hand, industrial base on the other, but also political urgency around resilience, competition, cybersecurity. On the regulation side, the EU has already set global benchmarks. Think about the GDPR, but also more recently NIS2, DORA, the AI Act, Cyber Resilience Act, all of which implicitly require hardware levels assurances in identity, integrity, encryption, and resilience. And then turning this into an industrial bet means positioning Europe as the place where secure microcontrollers, security enhanced processor, crypto accelerators, post-quantum chips are designed, certified, and manufactured. And such chips will become mandatory building blocks for example, banking, for critical infrastructure, but also for public administration, for defense. In a world with rising cyber threats also in consumer IoT. So if Europe writes the rule book and supplies the chip, that's a good way to capture both the regulatory and industrial value. Then the second one, as I mentioned, was the specialized and energy efficient compute for AI. Because the current wave of Gen AI is dominated by, as we know, by a few US and Asian players providing general purpose GPUs at cloud scale. In Europe is unlikely to replicate that quickly, but it doesn't need to. As I mentioned, we do not need to look for areas where Europe needs to catch up, but where it can realistically lead. Because the European industry, for example, is strong in automotive, in industrial automation, robotics, in telecom, all of which need highly optimized, deterministic, and energy efficient accelerators rather than generic data center GPUs. They're just that. And then if you think about neuromorphic computing, in-memory computing, AI accelerators, these are all aligned with strict safety and reliability requirements that are all areas where European research and companies have already a foothold. So aligning funding, of course, demand from OEMs or operators and industrial strategies around these niches could create, European champions whose products are central for cars, for factories, for networks. And then the final, as I mentioned, was, let's say, more long term. It's on, photonic and quantum platforms. So in terms of research, Europe already leads in several quantum research metrics, as well as integrated photonics or quantum communication. But as we saw also from the radar, these technologies are very early, but the strategic impact is large. If you secure quantum communication, optimization, simulation, accelerator for AI and data center networking. Here, the bet is not mass market volume in the short term, but it's establishing Europe as the origin of key IP, platform, and early stage system. So if European players start owning the IP and early markets, they can later license, co-develop, and maybe scale manufacturing with partner while keeping strategic control. So, these are my three bets. And just to sum up, so across all three bets, what makes them attractive is the alignment of policy priority. So we have sovereignty, green transition, cybersecurity, existing industrial strengths, automotive, even though it's been struggling for the past few years, but still one of the strongest sector in Europe, power electronics, photonics, chips, and emerging global demand. And they reinforce each other. So, this year I see this three is investing in these three clusters as creating network effects across Europe's digital and industrial landscape.
Okay, okay. I like that, especially because the next question actually goes a little bit against that. But I really like that you focused on the strengths of Europe rather than, oh, what are we doing wrong? No, we have to take advantage of what we already have and the strengths that we already have and build upon that. And that was an interesting use of a reverse card that I really enjoyed. But the next question I had goes directly against that, and I do apologize. But you did mention that obviously there are areas where Europe is still catching up and lagging, and specifically in the semiconductor industry and relating to these emerging technologies, where do you think that EU is still lagging, or what should we could be lagging in terms of, okay, to build on those strengths, where do we have to invest?
Yeah, absolutely. So let's translate lagging into how to fulfill these opportunities. So because when we want to translate the big bags, for example, that I just explained into concrete opportunities, I think that we need to look at different sides. So, and the analysis must follow, market dynamics. So who's buying, what they value, where incumbents are strong, where gaps exist that Europe can fill. For example, in secure semiconductors, regulatory pressure, cyber risk are creating a very fast growing global market for hardwares with trust built-in devices or trust in payment systems or industrial controllers or in cloud environments. Then if you look at financial services, energy, transport, public sector operators, they increasingly need chips that can demonstrate resistance, security, hardware-bound identities, strong cryptography. And then if we want to, and then here is where European vendors already play an important role in, for example, smart cards, e-passports, also boosted by new regulation, payment terminals, and so on and so forth. Then if we look at the compute side, here market dynamics are different. Hyperscale training for Gen AI and large foundational models is mostly an oligopolistic market with few big players and severe entry barriers in terms of capital, ecosystem, and software. But on the other side, a much larger long-tail market is emerging in inference and edge AI for verticals, again with cars, with industrial robots, with drones, medical devices, telecom. And customers in this market often care more about predictability, safety certification, energy efficiency, and lifetime support rather than focusing on peak performance, for example. And for example, then if you think about general purpose GPUs, many complain that these are too power hungry, they're too expensive, they're too complex for their specific use case. And this is exactly where specialized accelerators, neuromorphic computing can succeed, and so on can succeed, especially if co-designed with European OEMs and integrators. So the gap today is that many European startups and research products struggle to get from prototype to scalable product lines and industrial grade manufacturing. That's also an issue in terms of funding. I mean, there are other gaps, but I know that we are almost out of time. So just to conclude, structurally across all the different opportunity areas, Europe faces common horizontal gaps. There is access to advanced manufacturing nodes and specialized processing technologies that is limited, especially for smaller design houses. Then there is dependency on non-European tools and IP that creates exposure to export controls and licensing. Then there is the value of that, as I mentioned, between lab innovation and commercial scale, which remains wide. And addressing these gaps through shared design and prototyping infrastructure, coordinated public procurement, targeting financial instruments. This will determine whether these opportunities can become actual European market position or they are captured by other, while Europe remains primarily a downstream user. So finally, across all the cluster, the common pattern is quite clear. So the biggest opportunity are not in chasing the most commoditized parts of the global semiconductor market, but it's in high value, high trust, high differentiator niches where Europe existing industrial base, regulatory environment, and research system can be turned into potentially scalable businesses.
Okay. Final question, and then we'll move on to close and Q&A by folks that might want to ask questions. But the final question would be, okay, to be able to accomplish that you just mentioned, from a political side, from the EU, what would we require for that to happen? Or what can be helpful for the EU to do to provide that?
Yeah, absolutely. Because all those big bets and things that I just mentioned, they're mostly ambitions, but we need to turn these ambitions into reality. And I think that Europe should start by thinking of semiconductors not as yet another sector to support, but as a foundational capability for its economic model, its security posture, and as well as societal goals. And this require more of a coherent mix of investment, regulation, skills policy, international strategy, rather than just than has been, typical in past industrial initiative, that this, coherent mix was lacking. For example, funding alone, while essential, is not enough. Equally, regulation alone, even if world leading, cannot compensate for weak industrial capacity. So the challenge is to orchestrate several levers so that they reinforce each other rather than pulling in different directions. The first element is scale and predictability of investment. If you look at advanced semiconductor capacity, this demands multi-billion euro commitments that span political cycles and outlast changes of governments. So companies will only locate design centers and fabs in Europe if they can trust that support will not evaporate halfway through a 10-year investment horizon. So we're talking long term. And this calls for, dedicated European level financing instrument that blend grants, guarantees, and patient equity, complementing national efforts and private capital. And this instrument must be also sizable enough to matter globally, but also focused, favoring projects that anchor high value activities in Europe and are aligned with the strategic bets discussed earlier. Then we have, there's a matter of, talent and human capital, which is essential. Europe already produced strong engineers and scientists, but there's always a structural mismatch between what, for example, in this case, the semiconductor ecosystem needs and what the education and migration system delivers. So I see that the EU and the member states should work with industry and university to create clear, attractive career paths in specific fields, supported by scholarship, by industrial doctorates, and continuous training. At the same time, immigration policy should make it straightforward for highly skilled, specialized, ship designers or engineer from abroad to settle in Europe. Then, final 2 points. There is a point on regulation. With regulation and public demand are the levers that can provide the pull side of the equation, with Europe's distinctive strengths that lies in its ability to define norms that others then eventually adopts. But all of this, must be balanced carefully with competition policy, without a willingness to use EU own market to scale its champions. It will be difficult to sustain leadership in any of these strategic bets. And then finally, Europe has to situate its semiconductor strategy within a broader geopolitical context. No region can be fully autarkic in semiconductors. The supply chain is intrinsically global, spanning equipments, materials, design, and packaging. The EU must therefore deepen partnership with like-minded countries while deliberately diversifying away from single points of failure. So if all of these elements come together, with serious long-term investments, a robust talent pipeline, a dense and open ecosystem, smart and coherent regulation, and then strategic international partnership, then the emerging technologies on the radar need not be something that happens in Europe. That can instead be technologies that are conceived, enabled, and scaled from Europe, with the semiconductor industry at the core of this story.
Okay. Thank you so much, Lapo. We've gone a little bit over time. However, there's still time for anyone who's present, who's attending the webinar. If they'd like to ask a question, please use the chat. I don't believe we have any questions yet, but we still have a couple of minutes. I would just leave off with these key takeaways from this presentation. I would like to thank Lapo, obviously, and the folks from Trust IT for helping us out with this webinar. And thank you for everyone attending, and leave you with these key takeaways. I hope this was a useful use of your time. And if you'd like to use the chat to ask a question about anything you heard today or saw today, feel free. We're still here until top of the hour, which I think is right now, but I don't think we're stopping mandatory at the top of the hour, so we still have a few minutes if you'd like to post your question. Do we have any questions? Okay, so there's a question regarding the recording. Yes, it will be soon uploaded to the All Pros website, the recording of this call. Um, do we have any additional questions that we know of? I don't think so. I think that's it. Yes. Oh, yes, and a good point. Next week, on December 17th, we'll have the next webinar on the series. This one more focused on edge computing and how it relates to the semiconductor industry in Europe. So I hope you all can attend if that's a topic that is of interest to you. And if not before, we will see you next week at the next webinar. Again, thank you very much for Trust IT for allowing us to conduct this webinar and to the
Thanks,
European
Luis.
Union for funding this project. And thank you very much for Lapo for your time and valuable insights into the emerging technologies industry. Thank you
Yeah,
so
Thanks
much.
for having me.
Thank you,
thank you,
Thanks.
everyone.
thank you,
Bye-bye.
everybody. This concludes our sessions. This very, very helpful session. So, as I mentioned in the chat, don't miss our next week's webinar with Luis once again and with Alexandra. So, thank you for joining us today and have a great day, everyone.
Thank you. Bye-bye.
Bye bye.